In the last video, I built and modified the code to support this diagram, with the exception of the bank class, which I'll be working on now. Okay, so let's build the bank class. I'll create it in the dev.bank package. Every bank has a routing number that uniquely identifies it. This will get set when I create the bank, and it shouldn't change, so I'll make it final. Each bank instance will keep track of the last transaction ID. This should be unique for every transaction because it's going to be changing constantly on the bank instance. I don't want it to be final, but I do want it to be private. By the way, I've made routing number public, it's final, and an int, so client code can't mutate it, and it's a matter of public record for most banks. I could have made this private and added a getter, so if you did it that way, that's perfectly acceptable. A getter is probably good practice anyway. Okay, moving on. I also want a collection of customers. I'm going to make this final and a map, so I can look up a customer by the customer ID. My key type is string, which will be the 15-digit customer ID, and the value is a bank customer. I'll call this field customers. Now that I have the fields, I'll generate a constructor, but I only want to include the routing number. Now that I have this constructor, I'll add code to instantiate my customer map here. I'll make this a hash map. It's not really important that it's ordered, but it's more important for retrieval to be faster. For this class, I don't really want getters, though one for routing number might make sense. Instead, I just want a public method to get a bank customer, and that'll be called getCustomer. It'll take a string ID, the customer's ID for the bank customer I want to retrieve. I'll look up the customer by this ID. I'll return this customer for the moment. I can't get a customer unless I have some setup on my bank, so I need a method to add a new customer. I could return a boolean to indicate success or not, or I could return the customer object created, but I don't want to do that here. Instead, I'll keep this simple and just make it void. It will take a name, an initial deposit for the checking account, and an initial deposit for savings. I'm going to create a new bank customer instance, passing the name and deposit amounts. This is how we created a customer in the first challenge. The difference now is that I can only create a bank customer instance from code in classes in this package only. I'll add this new customer to the bank's customer map using the string I get back from getCustomerID as the key. Finally, I'll code the very important method doTransaction. I will set this up as a public method, returning a boolean which will be true if the transaction was successfully processed. It will take the customer ID, a bank account type, and an amount. I will get the customer instance using the ID. I'll have this method return false as the default value. Continuing after I've retrieved my bank customer, I'll make sure I got a valid customer back. I'll have an if statement checking if customer is not null. If that's the case, I can get the account from my customer using the account type. If customer is null, meaning I couldn't get it based on the ID passed, I'll print out that it's an invalid customer ID. Okay, so now I have to make sure I got an account back from that, so I'll check if account is not null. If account exists, meaning account isn't null, I'll check if adding that amount to the balance would result in a balance less than 0. This would only happen if the amount is negative and there weren't enough funds for the withdrawal. If this is the case, I'll print insufficient funds. If the amount is positive, a deposit in other words, or the previous check wasn't true, meaning there's enough funds in the account for this withdrawal, then I'll save the transaction and return true. Okay, so that's the banking application. But how secure is it? Let's go test it out in the main class's main method. First, I want to create a bank instance. I'll insert this code above the bank customer Joe equals null statement. I'll create a variable bank and assign that a new bank passing that a routing number. I'll add a bank customer Joe with the same deposits as before. I need to retrieve Joe from the bank's method, so instead of assigning null to Joe, I'll assign the result of the getCustomer method on my new bank. I know I started with 10 million as the first bank customer ID, so that's 8 digits. I'll add 7 leading zeros, 10, and another 6 zeros to get our 15-digit customer ID, which should give me Joe. And I'll print that out. Running this code now. I get the same output as before, but I also get an exception where I try to clear the account data I get back on line 28. This is the benefit of returning an unmodifiable collection. I'll remove those last three statements. I'll add some funds to Joe's account, calling the doTransaction method on bank to do it. This method returns a Boolean, so I'll put it in an if statement. I'll pass the customer ID, checking for the account type, and $35. If that's successful, I'll print out Joe's account again. Running that code, you can see Joe's checking account balance has increased. I'll copy that last if statement and paste a copy right below it, changing the amount to -535 and running this. You can see I can empty the account to a zero balance. I'll change that to withdraw a penny over. Let's see what happens when I run it. We get confirmation that the withdrawal cannot proceed due to insufficient funds, and as a result, the checking amount stays at $535. I'll undo that last change because I want to have a couple of good transactions on this account. Next, I'll get the checking account from Joe's bank customer instance. I'll retrieve them via Get Transactions on Checking, and I'll print them. Running that. You can see my transactions printed in a format you'd see used by bank, i.e. large numbers with lots of leading zeros. Notice they're not in order. The returned map is not guaranteed to be ordered in the same manner as the map from which it was created. I'll see if I can modify those checking account transactions next. I will try to add a new transaction directly into the transactions variable. Running this code to see if it works, I get an unsupported operation exception, so that's a good thing. I shouldn't be able to just modify the transactions once I get a reference to it. But is this code really safe? I'll undo that last change, removing that statement altogether. Instead, I'll loop through the transactions and I'll just see if I can tamper with each individual transaction. I'll add a separation line. Looping through the transactions of my local variable, I'll set the customer ID to 2. I'll change each transaction amount to $10,000. And I'll again print these transactions. Will this work? Let's see. You see that it not only compiles and runs, but it looks like my transactions have changed. Have they changed on Joe's account or just on this copy? To answer that question, I'll get Joe's account again and the transactions on that. I'll add another separator line. I'll call Get Account directly on Joe, obtaining the checking account, and chain a call to get transactions, so I'm again getting transactions from Joe's data, not local variables. I'll print these transactions. Running that. Hope you're cringing a little. Ouch! Our client can change data on our bank customer's account. We put in a lot of effort to prevent this behaviour. What could we do to fix this? Maybe we want to create a deep copy of the account. This would mean creating a copy not only of the transactions list, but each individual transaction as well. I could also return a different kind of map from this method. In fact, this is what I'll do. I'll go to the Get Transactions method on bank account. Instead of returning an unmodifiable map containing mutable data, I'll instead return a map of immutable instances, strings. This will provide the same behaviour without exposing the data to dangerous side effects. To do this, I'll change the return type of this method from returning a map keyed by long with transaction values to still be keyed by long, but with string values instead. I'll next set up a local variable, a map, again with the key long with a value of string. I'll call that txmap. I'll set it to be a new linked hash map. I'll loop through the map's entries. I'll insert the same key, so tx.getKey, but the value won't be the transaction, but rather it will be the string value for a transaction. I'll return this map. Now my main method doesn't compile, and that's a good thing. I haven't exposed the transaction instances to the client, but I've been able to use the transaction class in my model. I'll comment out that whole for loop code. Instead of that code, I'll try to clear Joe's transactions. I'll get the checking account, get transactions on that, and chain a call to the clear method. This code compiles and runs, but it has no effect on Joe's transactions. I passed back a modifiable collection with immutable data. This was more secure than passing back an unmodifiable collection that has mutable instances. You want to be really careful about what you return from mutable classes, because the mutable object could be buried several layers deep. You could try to do deep copies, or if there's no real reason for the client to have access to the full functionality of the instances, return alternative immutable instances that contain the information they may be interested in. Okay, so I hope you got something out of that and can see the value of using immutable classes. Don't assume just using an unmodifiable collection is going to be good enough. Combining immutable classes with unmodifiable collections gives you the best protection for your data. In the next video, I'll be doing a review of constructors. There's a surprising amount of complexity around constructors, so I want to take another look at them. I'll follow up with examining enum and record constructors. See you in the next video.